Hello everyone. In this lecture, we want to discuss something called present value of an investment. So everybody knows about the compound interest formula already. So A equals P times 1 plus I to the exponent of N. And sometimes instead of giving the value of the principal and asking to find the final amount, capital A, the given information is actually capital A, the final amount, and that's what we know. And we want to work backwards and find the principal P. So if that is the case, then we have to do some rearrangement here. I'm going to divide both sides by 1 plus I to the exponent of n. So A divided by 1 plus I to the exponent of n, and the right side also we divide by 1 plus I to the exponent of n. So simplifying the right side, we can easily solve for P. So we get P equals A over 1 plus I to the exponent of n. But using the negative exponent law, which we have learned already in the past units, we can write the power that is in the denominator in the numerator with a negative exponent. So this can be written as A times 1 plus I to the exponent of negative n. And this P is also known as present value. So we write PV equals A times 1 plus I to the exponent of negative n. So this is very similar to the compound interest formula, except that the exponent is negative this time. And the location of P and A are actually interchanged. We had A equals P times the bracket. Now we have P equals A times the bracket. So principal or present value can be used interchangeably. And we can write the formula using R and K, and the exponent is negative KT in this case, and this becomes the official formula for the present value. The value of K, as you know, is different, and it depends on the type of compounding involved in the problem. We have a question here. We will try to do it together. Rafi wants to invest enough money today, and that word today is the key word, to have $8,200 for college tuition in 3 years. So he wants to have $8,200, but he doesn't want to have that money right now today. Currently, he doesn't want $8,200. He needs this money not now, but in future. That is in 3 years, because he's not going to college right now. He's going to go to college 3 years from now. That's his plan. So this $8,200 is never equal to P or the PV or the present value or the principal, because that is the money that he needs to have in future. So that's the final amount that he wants to have down the road after 3 years. This means that it's extremely important for you to read the question very, very carefully 5 times to fully understand what kind of financial math problem is in front of you. So this A is $8,200, and it is not the P. And it says that the money is required in 3 years. So that means that time is 3 years. If he invests his money at 5.5% per annum, which means the annual rate of interest expressed as a decimal would be 5.5%, or 0.055, compounded monthly, the question says. So that means that K is basically 12. We know our chart, we know the K values. We know if interest is compounded monthly, K is 12. How much does he need to invest now? Again, I underline the word now. So we want to know how much he needs to invest today, right now, currently, presently, at present, such that with this investment condition, his money today grows to a bigger amount of $8,200 in 3 years. That's what we want to find out. So the meaning of present value is that is the amount you need to have presently, at present, right now, you need to go to the bank right now, open up a bank account and deposit PV dollars so that the money stays there and it earns interest for you. And after 3 years, with the rate of 5.5%, it grows to a bigger amount of $8,200, which is exactly what you need to pay for the tuition, college, or whatever you want to do with the money in the future. So that's a present value type of problem, financial problem. So obviously, we're not going to use the compound interest formula that we used in the past. We are going to use the present value formula. So step one, we write the formula down. Remember that the exponent is negative. If you make a mistake, all the calculations will be wrong, all the answers will be wrong. You have to be very careful, bottom line. So PV equals $8,200, 0.055, that's the rate of interest, compounded monthly. Now the exponent would be negative 12 times 3 years, right? So when you're inputting numbers in the calculator, you have to be very careful about the bed mass. When you punch into buttons, perhaps when you press the power key after you close the bracket, you better open a new bracket and you put all these products, 12 times 3, whatever it is, with the negative sign, all inside the bracket separately so that you get the right answer. Otherwise, you know that calculators are working based on bed mass. So if you mess up the order when you're punching the buttons on the calculator, you may get the wrong answers. It's very easy to make mistakes. So now I'll do the same thing. So 8,200 times 1 plus 0.055 divided by 12. And I'm going to raise it to the exponent of negative 36, basically, because 3 times 12 is 36. So I got 6955. So 0.35. Okay, so you see that this answer is less than $8,200, and that means that it is actually correct. We were expecting to end up with a less amount because this is the amount of money, just under $7,000, that you need to have today in your account so that this money stays there and earns interest, 5.5% interest compounded monthly after 3 years, and it will grow to what you actually need to have after 3 years, which is $8,200. So the present value of $8,200 in 3 years is equal to $6,955.35. That means the value of that $8,200 down the road in 3 years, the value of that today is this much. But this much money will definitely stay in the account and earn interest. Eventually, it will become $8,200. So this is the amount that Rafi needs to have in his account today so that he will have $8,200 down the road in 3 years. This is a word problem. We need a final closing statement for that. Obviously, you're going to write that down. Sometimes present value financial math problems are used to solve loan problems. A car loan of $5,000 at 12% per annum, compounded monthly, is due to be repaid in 3 years. So I'm going to change this monthly because we have the same compounding there. So I'm going to write biweekly here. Okay. So a car loan of $5,000 at 12% per annum, compounded biweekly, is due to be repaid in 3 years. And I'm going to change this 3 again to some other number, to, I would say, 4 years. Okay. How much is the present value of the loan? Okay. So what does that mean, basically? It means that you wanted to buy a car or something, and you borrowed money okay, from the bank, you went to the dealership, you bought your car, you're happy driving, whatever. And right now, the bank says, okay, you have to pay $5,000 at 12% per annum rate of interest, compounded biweekly, and you have to pay this in 4 years, okay? And you start negotiating with the bank, and you say, okay, if I don't want to wait 4 years to pay off my loan, how much should I pay today, right now, currently, at presently, such that we just wash our hands, sign the contract, and don't even see each other again? How much should I pay you now so that you just accept my debt is paid off completely? Okay, that is the question. Basically, what is the present value of a $5,000 loan at a rate of 12% per annum compounded biweekly, which is due in 4 years? So this is what we want to figure out. If you don't pay your loan off today, then you have to pay $5,000 in 4 years. But if you pay today, you will see that you may uh, get a break. So we're going to see what the numbers are telling us. Always we start with the formula. Exponent is negative. $5,000 is the amount of the loan. The rate of interest 12% compounded biweekly. So the chart here, it says biweekly k is equal to 26. So now the exponent is negative 26 times 4, because this loan is due in 4 years. So now we can use the calculator to figure this out. 5,000 times 1 plus 0.12 divided by 26 raised to the exponent of negative 26 times 4 is the exponent, and we get 3,097. So $3,097.34. Okay. So what is the meaning of this $3,000? This means that if you go to the bank, or you go to the creditor, you go to the person from whom you borrowed money, if you go there and say, hey, I want to cut a deal with you, I want to pay $3,097.34 right now today, and we just sign the contract off that I have paid my loan off and I don't owe you anything, and we're done with business, basically. Okay, this is the situation. So if you don't want to wait for 4 years, if you don't want to pay a big amount of $5,000 in 4 years, 12% per annum rate of interest compounded monthly, if you don't want to do that, then your option B is to pay $3,097.34 cash right now today to the bank or the creditor, and then they're going to say, okay, you know what, you don't need to worry about the 5,000. So you pay less, basically, if you pay that big amount of $3,097, $3,097 today. You understand? So this is the present value of that $5,000 loan. I hope with these two examples, with the college tuition and the car loan problem, you understood the application of the present value type of financial math problems. Of course, practicing is a key thing, so keep practicing. Thank you.